So this question asks us to find the equations of the lines of two sides of this parallelogram. And these lines are BC and DC. But we don't know what the point C is yet. So at first the question seems pretty difficult, but it's actually not too bad because the shape is a parallelogram, which means that this line and this line are parallel, and also this line and this line are parallel. And if the lines are parallel, it means they have the same gradient. So we can find the gradients of the lines BC and DC by looking at the gradients of the lines AD and AB. So first we find the gradient of the line AB, which will be the same as the gradient of the line DC. So the gradient of AB is just a simple rise over run type thing. So we are rising 6 and we're running 1, so the gradient is just 6. So now we know that the line DC has a gradient of 6, and we can already see that it passes through the known point 6, 2. Now using the normal way of writing a linear equation y equals mx plus c, we can substitute the known point in along with the gradient, and then we've only got one unknown to find. So the known point passes through the y coordinate 2, and then the m we said before is 6, and it passes through the x coordinate of 6 plus c. So let me just zoom out for a second. That's going to be 2 equals 36 plus c. So c must be 34, or rather negative 34. So the equation of the line DC is y equals 6x minus 34. So now we do the same thing for the other side. We're going to find the equation of the line BC by first finding the gradient of the line AD, which will be the same as the gradient of the line BC. So again, rise over run gives, and we've risen 1 and run 4. So the gradient is a quarter. Again, just doing the same thing as before, we use the pieces of information we've got. The line BC has a gradient of a quarter and passes through the known point 3, 7. So now we're going to sub that into the equation y equals mx plus c. So the y coordinate is 7, the m value is quarter times the x value of 3 plus c, which is going to give 7 equals 3 quarters plus c. So c must equal 6 and a quarter. And to make it easier for ourselves, 25 over 4. So we can now say that the equation of the line BC is y equals a quarter of x plus 25 over 4. And that's the first bit of the question done. We found our two equations here and here. Now the next part of the question asks us to find the coordinates of the point C. There are a couple of ways of doing this. The first way is to solve the simultaneous equations that you found in the first part. So you found the equation for the line BC and you found the equation for the line DC. So when you solve those for x and y, you'll get the coordinates of the point of intersection, which is of course C. The other way of doing it is actually remembering that we've got a parallelogram and considering the side lengths. So in the case of our parallelogram, the side lengths of BC and AD are the same, and the side lengths of AB and DC are the same. And so using this, you can figure out where point C is, and that's what I will show you how to do. Now, we've zoomed close to our parallelogram, and what we're going to do is we're going to break it up into some triangles, or rather like make triangles next to the sides. So you can see that this line here, this purple line I'm drawing, that's the vertical component of the line AB, and this line here that I'm drawing is the horizontal component of the line AB. So that all makes a sort of triangle thing. So now I've added another triangle to the line DC, and you can see that the triangle I've drawn for AB and DC, they're the same. And basically we can use this triangle just as we got from A to B to get to D to C. So to get from A to B, we had to walk across 1 and then go up 6. And this triangle over here for DC will be exactly the same. Walk across 1 and go up 6. So I've just written that down. And then to get from D to C, we can do basically the same thing. So to get from 6 to a question mark, we have to add 1 to the x coordinate, and we have to add 6 to the y coordinate. So it looks like we've just found the coordinates of point C, and they are 7, 8. And so now I will show you the simultaneous equation way, just to show you that we get the same answer. So here are the two equations we found earlier, and we'll solve them through substitution. Multiplying both sides by 4, subtracting x from both sides, adding 136 to both sides, dividing both sides by 23, and I've just done the long division there to get the answer x equals 7. Now we substitute x equals 7 back into one of our equations. I'll choose the second one here. Y equals 1/4 times 7 plus 25 over 4. This gives us the answer y equals 8. So the coordinates of point C are 7, 8. Which is exactly what we found before using the other method. I think the other method is quicker and nicer, and you actually can figure out the coordinates of point C using the other method without doing the first part of the question, which is quite handy. The final part of this question is to find the coordinates of the point of intersection between the two diagonals. So the diagonals are AC and BD. And we found the coordinates of C before, that was 7, 8. Now, using the geometric properties of the parallelogram, you can ascertain that the point of intersection between these two diagonals will be at the halfway point along each diagonal. And we can use a similar deconstructing these lines into triangles method to what we did before. So we will start with this green diagonal BD, and you can see that BD goes from 3, 7 to 6, 2. And we can make a triangle that looks something like this. Where we have gone vertically from 7 to 2, so that's a distance of 5. And we've gone across from 3 to 6, which is a distance of 3. So as you may have figured out, to get to the halfway point, we need to go halfway down from point B and then halfway across towards point D. So halfway down will take us from 7 to, what's half of 5? 2.5. 7 minus 2.5 is 4.5. And then to get halfway across, we will go from 3 towards 6, but only half that distance. So 3 divided by 2 is 1.5, so that means we're going from 3 to the point 4.5 for the horizontal coordinate. So we figured out that the halfway point of the diagonal BD is at the coordinates 4.5, 4.5. Now for AC, we do a similar thing, drawing in our triangle first of all. So a distance across from 2 to 7, that's a distance of 5. And then a distance up of 1 to 8, that's a distance of 7. And again, we're going to go halfway up and halfway across. So moving across from 2 to 7, a distance of 5, but we're going only halfway, so we're going to just add 2.5 to 2. So that goes to 4.5. And then for going up, that's a distance from 1 to 8, which is a distance of 7, only going halfway, so we only add 3.5 to 1. And what do you know? We get 4.5 again, which means the halfway point of the diagonal AC is located at the coordinates 4.5, 4.5. And earlier I did say that we knew that the diagonals would be intersecting at this halfway point, and I've just proven that twice over. So we've answered the question, but it's a good idea to recognize that you had a choice of two methods here. You could have gone down the simultaneous equations route by finding an equation for the diagonal BD and an equation for the diagonal AC, and then solving those two equations simultaneously, or the geometry kind of method, which I've just shown you here, of adding extra lines to your diagram and just being really careful in terms of assigning lengths to different lines and things like this.